cool cats and kittens. This is going to be chapter 7 continued. There's your homework right there, page 187, number 16 through 22. All okay. Cool. All right, we're gonna move ahead. This is all gonna be due on Thursday. I'm planning on doing a Zoom meeting on Wednesday sometime in the afternoon. All the deets, that's stupid. All the details is going to be posted for you guys, so you guys can go ahead and see all that. Cool. All right, so we're just going to continue, just like as a quick little review, a scatter plot of a house price, whatever. We don't really need to see it. For houses, the price is thousands in dollars, and the size is square feet for houses sold. Here's your equation. Okay, cool. Remember, this right here is your prediction, right? The little hat. That's going to be your prediction. Okay, so yeah. What does the slope 94.45 mean? Well, remember, slope is y over x. All right. So your slope is going to be, it's 94.45. The y value is price, so dollars per, right? It's 94.45 over 1. So, it's dollars over feet squared, or thousands of feet squared. Okay. So, sorry, I totally messed up there. I wasn't careful. It says thousands of dollars, so it's 94.45 thousand, right? $1,000 per 1,000 feet squared, because it's 94.45 over 1, right? On top is the money. On the bottom it's going to be your square footage. Okay, so that's that. What are the units of the slope? Kind of talked about it. It's thousands of dollars per 1,000 feet squared. Your house is 2,000 square feet bigger than your neighbor's house. How much more do you expect it to be worth? So it doesn't really matter for part number 6. It doesn't really matter how big your house is or your neighbor's. Is just $2,000 more, right? So you can just do predicted price of your house is equal to negative 3.117 plus 94.45 times 2,000. Okay, so that's 94.45 times 2,000. Cool, minus 3.117. Oh, crud, I totally messed up again. Because size is already in 1,000 feet, you actually should just plug in 2, not 2,000. It's just 2, because it's already in thousands of feet. And to be honest, like I can catch myself like that because the number that I'm plugging in my calculator right now yielded out like a really, really big number, which doesn't really make sense in the long term, right? Like you can kind of predict it using like that kind of logic that, oh, this number like stands out too much. Yeah, so 188.9 is equal to 185.783. So your house is probably worth about $185,783,000 more. Right? Remember, it's in thousand. Is the y-intercept negative 3.117 meaningful? I would say no, it's not meaningful. The reason why it's no is that the y-intercept is where we began, right? Is where we began. The negative 3.117, like, you can't have a price that is negative 3.117. Like, you can't have a house that is negative dollars. So the answer is no, can't have house negative value house. Because remember, the y-intercept, the y in this problem, all right, The y in this problem would be the price, right? Because the price is by itself, so that's the y value. So the y-intercept is a measurement of price. Okay. All right, moving on. All right. During this time, I wanna make sure that you guys are watching the video. I want to keep track of people who are watching because I'm pretty sure not everybody is watching. So this is my offer right now. In the Google Classroom, in the comments section, of this video and this assignment that I posted this assignment, I want you guys to go ahead and comment, write a compliment about me, I guess. Yeah, write me a compliment in the comment section of the Google Classroom, not of this video, of the Google Classroom, where I posted this assignment. And if you do that, I'll give you guys a point of extra credit because I'm just curious who's watching these videos. So go ahead and pause and do that. So remember, not in the YouTube video, but in the Google Classroom. Write a comment in the assignment about this video. Okay? Compliment. If it's not a compliment, I'm not giving you extra credit. All right. Anyways, back to our talk. Our B, our slope, is determined by this formula right here. Okay? S of y and S of x are the standard deviations of y and x. And if you guys remember R, that's your correlation coefficient, right? So R is your correlation coefficient. So we're just going to keep that in mind. Okay. All right. So yeah, it just follows that formula. You do standard deviation y over standard deviation x and times by R, and that's your slope. Okay. So I want to look at this formula. I want to find the slope. So really easily, I know my formula is, correlation coefficient times standard deviation y over x. So I have all the things that I need here. So I'm just going to make my substitution and have an answer out. 0.91 grams. That's going to be my slope. Cool. Nothing too tricky there. Okay, in our model, we also have an intercept. It's A. The intercept model is built from this. This is derived from your intercept is built from the means and minus the slope. Really, our y-intercept is always in a unit of y. Okay, our y-intercept is always in a unit of y. The intercept is built from the means and the slope. Okay. Some of you guys are probably looking at this and you're like, how the hell did he come up with that formula? It's kind of a deviation of this right here. Right? Like this should be our basic formula. Our prediction value is equal to A, which is our y-intercept. Right? Ow. Which is our y-intercept, plus B, which is our slope, times X, whatever our, value that we're putting in. And essentially what I'm doing is I'm solving for it. I'm essentially solving for it. A is equal to y hat minus b x. I'm just subtracting bx to the other side. The reason why I'm using the means is, remember, the mean is the middle, right? The way that I'm doing this is I'm finding my y-intercept by finding the middle. So instead of having my prediction, I'm just calling it my middle, my mean for y, minus b, and my x for that, because that's going to give me the most accurate number for my y-intercept. Right? Because it's the number in the middle. That's what the mean is. Okay. Moving on. Sorry. Oh, God. I'm freaking out. Okay. So we have that right there. We already did this 8.4 kind of, what I'm doing is find my y-intercept. If you guys noticed right here, 24.8 is my y, average for y. 0.91 is the slope, and that's the slope that we got from this last this last example up here where we found out that the slope was 0.91, so I'm just making a substitution. So that's b times 18, which is x bar, right? And I'm just multiplying through. And yeah, I'm going to get 8.4 grams of fat from there. And all this information is in this nifty little chart here that should be available to you. If not, then there are ways of finding it. But now I know that the equation for the least square lines is prediction of fat is equal to 8.4, which is my y-intercept. Remember, this is my A, this is my B, slope. And then protein is my predictor, what I'm trying to plug in to predict, right, is my independent variable there. Okay, so really the point of this lesson is just how to get A, how to get your slope. Okay, so there's just two formulas that you guys need to really memorize, that slope is your correlation coefficient times the standard deviation of y over the standard deviation of x. And then your y-intercept, okay, is equal to your y average minus the slope, so you need the slope, times x average. So that's denoted as b, and that's your a. To get a formula where its y predictor is equal to a plus b of x. Okay, all of these will lead you to this formula down here. Okay. To use a linear model, we should check. So it's the same three. We got to make sure it's quantitative. We got to make sure it forms a straight line or as close to a straight line as possible. And then that there's no outliers. Okay, we don't want outliers. Outliers mess up our thing. So these are our conditions. Remember, our conditions. Okay, this part right here, is there a relationship between the age of a bridge and its safety? I would say, yeah, there is a relationship. Okay, the correlation is a negative. So that should tell you something. That should tell you that, you know, if safety score is our Y, right? As if it's negative, if we kind of visualize it, it goes down, right? Our R goes down. That means it's a negative correlation. I would say that safety scores, remember, this is Y, this is X, and this is based off of that, right? That's that. Safety scores go down as age goes up. Right, as we're getting older, our safety scores go down. Now, that is not to say that 0.681, negative 0.681 is our slope, right? I'm not saying that that's our slope. That just gives us like a pattern that, you know, it follows a negative trend. Now what I want to do, so this is part one of it. What I want to do is I want to find my slope. So my slope B is equal to R, which is negative 0.681, times my standard deviation of Y, 1.0297, over my standard deviation of X, which is 30.75, right? That's my standard deviations. Okay. Now, if I do that, I'm going to use my calculator real quick. Negative 1.0297 divided by 30.75 times negative 0.681. So I know that my slope is about negative 0.0228. About. Next, I want to find my A. So A is equal to Y bar, the average of Y, minus B times X bar. So Y bar is that. X bar is that. So 5.2779 minus B, which is negative 0.0228, times 44.9. And then I'm just going to plug that in real quick. So 5.2779, right? Negative makes a positive. So plus 0.228 times 44.9. So it's 15.51. Okay, so my equation is safety score. So prediction of score is equal to my y-intercept, which is 15.51. Remember, this 15.51 is points, right? Minus 0.0228 times the age. Now, my question to you is our y-intercept meaningful? In which I will say, no, it is not meaningful. Okay, 15.51 is not going to be a meaningful number because our safety scores is only from 1 to 7. 15.551 is like outside of that range, if that makes sense. Right? So that doesn't make sense. All right, cool. Okay, let's move on. When we create linear models to fit our scatter plots, we always know two things. The slope of a line in a point goes to the what's called the mean. Right? The mean. Okay. It's a nifty name for it. Okay. It's really simple. All we do is it's point slope form. So it's y minus y1 is equal to slope times x minus x1. The idea is that they're just trying to get you guys a point to go through. This thing called the mean point is just like the middle point. It's like the best middle point that we have. That's what it means. Okay, so that's y. So I'm doing number 11 right now. So that's y minus y1, which is 20, is equal to your slope, which is 4, times x minus your b, which is 3. So this is number 11. So y minus 20 is equal to 4x minus 12. Y is equal to 4x plus 8. So that's your equation of that line. Okay, I'm not really going to talk more about that just because you guys should know how to do this. It doesn't really matter. Like maybe I'll just do 13 real quick. 13 would be y minus 12 is equal to 0.2 times x minus 80. And then you would just solve for y there. And that would be your linear model. Okay, cool. Finally, the last thing I want to do is I want to go through some questions on the homework that is going to be on today's homework. I'm already kind of thinking ahead, like what kind of problems that you guys are going to have. And I just want to go through two problems real quick. The first problem that I want to talk about is number, I don't know, let's go 18. Okay. In 18, it gives us that the correlation is 0.845. Predict what type of value. That's weird. Okay, sorry about that. Let me go back. Very interesting. Okay, this should work out. So that's your R right there. Okay, what would you predict if a home is 1 standard deviation above the size? Okay, so if we know that it's 1 standard deviation above, our R is 0.845. Remember, R is how closely these numbers relate, right? Like how closely knit are they? Like the closer to 1, the closer it is. So if it's a 1 standard deviation away, I would say that what would you predict that the price of a home about the price of the home is 0.845. What I would probably say, let me think here. I want to word it correctly for you guys. Let's think here. Sorry, this is super awkward silence right now. Okay, so if it's 1 standard deviation above, I would probably say that price is is 0.845. Says above, yeah, above standard deviation above what would you predict about the price of a home above the average price. So yeah, I would say price is above the mean of price, right? Because they would tie closely together. So if size is one standard deviation above, that means price would be one standard deviation above as well. That's what that would mean. Okay. Make this a little bit bigger. Yeah, that's what that would mean. That price would be it would be 0.845 above its own standard deviation. Same thing here. If home price of home is 2 below, right? Then what you're gonna do now, you're 2 the other way. So the way that you're gonna write that is that it's gonna be 0.845. Is if 0.845 represents one standard deviation, your correlation, I'm gonna multiply that by 2. Okay, so if I multiply 0.845 by 2, I'm going to get 1.69. So what that tells me is that price is 1.69 below the mean. The mean price. Right? So if you visualize it, price and size should tie in. So if size is 2 below, then that means price should be 2 below as well. And we're using 0.845 because that's how closely knit that they are together, that we can predict that 0.845 is about one standard deviation. Okay. The next problem that I want to go over real quick. God, this is so small. The next problem that I want to go over real quick is number 20. Yeah, 20 is a really interesting problem as well. Explain the slope and sign about slope. Like, that's simple. The slope is 0.61. 0.061. There's nothing too tricky about that. The 0.061 is just going to be, as the price increase, as the size of a house increases, the price, increases as well. That's what it's kind of saying. What would you predict for a 3,000 square feet house? I would just plug 3,000 in here and then just get a number out. That's nothing too crazy. Okay, this is a little bit more interesting. They're saying that a 1,200, whoa, that's so awkward. They're saying that a 1,200 foot home, 1,200 square feet home is $6,000 less than what you would expect to pay. Okay, so you're saying that it is $6,000 less. What we're gonna do right now is we're gonna actually test that. We're gonna take 6,000 and we're gonna plug it in. Okay, so if I take 6,000 and plug it in, I get 47.82 plus 0.061 times 6,000. So the asking price would be 413,082. So remember, this is in thousands of dollars, right? So the asking price is 413.82. What it's saying that it's $6,000 less. So that tells us that our prediction would be more, right? Because it's saying the actual cost is less. So what is 6,000 called? 6,000 is called a negative residual. Remember that? When your prediction is more than your actual, you have a negative residual. Right? Remember, because you're gonna have a negative residual because of that. Okay. All right. That's about all that I really want to cover and talk about. Hold on, let me make sure about the residual. Sorry. Residual formula. Predicted residual formula. Actual minus prediction. So actual minus prediction. So if the actual is bigger than the prediction, you have a positive. So the actual is less than. Yeah, we're gonna have a negative residual here. Sorry, I'm like tripping out right now. Yeah, we're gonna have a negative residual because it's going to be below. The point is below it. Okay, so that's a negative residual. If you're above it, it's a positive residual. Okay, that's about all I want to cover. Hopefully this was pretty straightforward, and like doing those homework problems helped you guys out. Yeah, that's pretty much all I have for right now. Like I said, I'm gonna try to schedule a Google Classroom and post that up on Wednesday for you guys, so we can get together and start talking about any questions that you guys have. And this homework assignment is gonna be due on Thursday. All right, cool. See you guys.